Hi, I'm Alta, and this is Team Massa. Our hydro generator system works to create a cost-efficient way to offset electricity costs by utilizing the running water in a home, such as the shower water, your hose, or maybe even your running water from a sink to charge a battery. Our goal was to create a small-scale system as a proof of concept to choose components for a full-scale system.
Hi, my name is Aaron Magana, and recently well, not recently, this was a while back, I traveled down to Yuma, Arizona to meet up with Miguel Casares. Me and him got together to build the prototype with all the materials that were sent in. We were able to get in a basic water line system going with PVC pipes, hydro generator, elbow connectors, T connectors, and such. Um, we were able to build the system entirely, and we were able um, to run it with a few complications. Um,
Hi, I'm Miguel. Like Aaron said, on that day initially, we were able to get the whole system running. We were able to run water through it and have it powering the generator or having the generator produce power. That is, after that, Aaron had to unfortunately leave, which left the rest of the building and testing to me. Rest of the building mainly being um, gluing down all the PVC pipe together so it can withstand pressure and so forth, and then creating a system where the water flowing through would be less interrupted, as well as testing the water pressure at different points in the system. After it was all said and done, all the tests were done and everything was glued down. We were able to have an actual product, which we can actually show here in a little demo. So you'll be able to see the water going through the main line currently with the generator not producing power, and then we can go ahead and switch these ball valve connectors in order to divert the water through the generator. This allows us to maintain pressure as we're not splitting the water, and allow the water to go straight through as well. And we're actually producing water with the generator or power with the generator at this point. This system was put in place so that we could isolate the generator if we ever needed to, and so forth, just in case we need to run tests on it, or replace it, or repair it. And I'm going to go ahead and pass this on to Chantal.
Following the results of our demonstration and small scale proof of concept, we were able to determine that our biggest issue, which was going to be pressure loss across the generator, could be avoided using a smaller tube or pipe size compared to what your main line is. So, as the results showed, using a smaller pipe allowed more water to come through, less water at the same amount, increasing the pressure. Coming through was 80 originally. When it got done, it was 75, 80, somewhere in there. I don't remember exactly what the numbers were, but it basically stated that our thought process in decreasing the pipe size would then counteract any pressure loss that we were going to see across the generator, assuming that we can come up with a generator that's going to give you about a 5 psi drop when using it. So that's basically what our proof of concept proved to us, is that it's very possible to increase and counteract any pressure drops like that. Now, to actually implement this full thing into a full-scale system, you're going to need a much larger generator so that it actually produces power, and you're going to need it at the correct voltage. So most typical homes are at 240 volt. If it's in an apartment complex, depending on the size, it's probably running at 3-phase, so you're looking at 208 voltage. But that's in the future. You're going to have it designed, but the process will actually work. It's just a matter of how big of a battery you want to do, how much power you want to produce. It's not meant to power your house. It's meant to offset costs or be there in the case of an emergency. We would like to thank everyone for your time and have a good night.